Welcome to Chemistry with Caroline. In this video, we're going to look at an introduction to and how we synthesize sulfides. So sulfides are the analog of ethers, where oxygen is replaced by a sulfur atom. So an ether is an internal oxygen. So in this case, the R has to equal a carbon. It can't equal an H. So a sulfide is just an internal sulfur. So one within a chain with a carbon on either side of it. And of course, those carbons could be many different carbon chains. They could involve branching. So there's a whole host of potential sulfides that could be made. So the easiest way to synthesize a sulfide is to start out with a thiol and then put it in the presence of a strong base to deprotonate it and generate a good nucleophile so you can have a substitution reaction occur. So oftentimes in organic chemistry, we use numbers to indicate that something is happening in a series of steps for a reaction to occur. In this case, we have a pretty strong acid in the thiol. It's got a longer, weaker bond, so that's a lot easier to break. And then we have a strong base. We have O-. So this is methoxide specifically. It could be hydroxide or ethoxide, so a 2-carbon chain, but a negative charge localized on an oxygen. And those two will react immediately with one another when put in solution together. So we don't have to worry about the strong base reacting with the starting material. So the first thing that's going to happen for this reaction is the thiol is going to become deprotonated by that strong base, and that's going to generate the nucleophile for the reaction. So if I put my lone pair on there, methoxide is going to deprotonate my thiol, and those equilibrium arrows are going to look like that. And so that will generate my nucleophile, plus I'm going to have methanol, which is my solvent, anyway, for this reaction. So that's the first step, is generating the nucleophile. Then it can go in and attack my starting material. So let's go to the next slide and we'll draw that part. All right, so I've redrawn my starting material, and now I have my nucleophile here. It's just been generated by deprotonation. And so this can come in and attack as my leaving group leaves. So that's going to be an SN2 type reaction. And so I'd see inversion for an SN2 type reaction, so that H is going to pop forward during the backside attack, and my sulfur is going to come in opposite of wherever the leaving group is. And so now I have a sulfide because that sulfur is internal. It's inside those two carbon atoms on either side of it. So this reaction will be either SN2 for primary and some secondary systems, or it could go SN1 for pretty much all tertiary and maybe some secondary systems. There's a lot of variability there, but the retention of stereochemistry or the formation of a racemic product would tell me which one I got. So remember, if you started with a chiral starting material and the reaction proceeded through an SN1 mechanism, I would get a racemic mixture, whereas if it proceeded through an SN2, it would be a stereospecific reaction, and I'd only form the inversion product and not the retention product. The other nice thing about this reaction is that the nucleophile is a weak base, and so I have no competing elimination reaction, so I don't have to worry about alkenes forming, which means I can do this with any substitution of starting material, primary, secondary, or tertiary. So this has been a look at sulfides, what they are, and how to synthesize them. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.